let me start. So make sure you guys have the notes. Like I said, if you guys don't have the notes, right, you guys can get the soft copy one, the PDF version on our official website. Just type in Google, type in TTC Education. So the first link, the one without paid one, so you don't. Sometimes if you see some suspicious link, don't press. Especially we don't use ads one. So if you see, because sometimes right, if you see ads beside link, right? Sometimes it can be the scammer. They pay Google, so Google will put them up because they pay Google for ads for advertisement. So be careful of that. So we don't pay any advertisement fee, man. Okay. So just to let y'all know lah. Okay, but if you guys haven't get your notes right, because for today, right, it's actually the first day for Form 4 seminar. So if you haven't got your physical class notes, physical notes, you guys can request from the link. You just have to fill in your house address, and then you will get the notes from us. We will deliver the notes to you lah. So the delivery fee is totally free. Class is free, and also the notes is free. So everything is free lah for this class. Okay. Yep. So if you guys are ready, right, let me introduce you. So let me tell you how do you use these notes first. Now, so for the first few page, from page number 1 until page number 4, they are your short notes. So they are not everything you need to know. I mean, yeah, everything here you need to know, but they are not everything in chapter 2. So we only pick a several subtopic to put it here in the short notes in from chapter 2. Right, so from page number 1, you can see we put this part linear motion, and then in page number 2 we put momentum. All these are the short notes for those for the respective subtopics. And then also for page number 3, we also put in impulse and impulsive force. Page number 4, it's also same as impulse and impulsive force. So it's actually and also you can see at page number 4, right, there we have this safety feature of car. So later we will also do another essay questions related to this one. Okay, so target we target to do at least 3 questions, 20 marks questions. Because later on in your exam, right, I'm not sure whether you guys are familiar with the format already or not. At your exam, right, question number 9, 10, and 11, they will be consisting of 20 marks. Those are the long questions. So we will be doing 3 long questions, and it will be taking up around 2 hours already. So of course, in the middle, later after 1 hour, we will have a short toilet break. Then meanwhile, we will just keep on doing these 3 questions. Okay. So just to let y'all know and also at the back, right, starting from page number 5 onwards, there are all questions until page number 49. So we prepared 45 pages of exercise for you all to go home and do. So I can guarantee you these 45 pages of exercise definitely cannot finish in 2 hours one. Okay, confirm cannot finish in 2 hours one. All right. Now, so but let me also tell you all something. For the first, if I'm not wrong, 6 questions, or sorry, 7, 8. Yeah, for the first 8 questions, right, they are topical exercise. But at the back there, they are all from chapter 2, okay? Just to let you all know, from question number 1 until question number 8. Okay, so from page number 5 until page number 20, until question number 8, right? Those are the questions from chapter 2. So if you look at page number 21, that is one, midterm revision questions. This one onwards, right, starting from page number 21, those questions until the back, they are mixed one. We mix chapter 1 and chapter 2 exercise for you. But of course, I will not be doing chapter 1 questions with you all, because in normal class now, we are doing chapter 1 now. Right? We just ended chapter 1. But because chapter 2, we have done it during January until March. So most probably, I suppose you already forgot most of the things. So that's why we do revision now. Okay. Yeah, so and also in the upcoming week, right, that means starting from tomorrow. So tomorrow is Monday until Friday. The normal class, we will be doing chapter 3. So prepare your chapter 3 notes. And then because most of the school, right, you all will be having exam until chapter 3.1, the first subtopic only. So that means the first subtopic of the gravity. So it depends on our progress. If we can finish 3.1 by this week, this coming week, okay, tomorrow until Friday, then if that's the case, right, we can do revision again using seminar notes on the next week. Okay, so just to let y'all know the plan now, so that you guys can prepare, okay, yourself for your exam. Okay, so I will plan the class for next week, but don't worry, I'll try to finish 3.1 so that the next week we still got another 1 more hour to do revision. So then remember this midterm seminar notes don't throw away. Keep it and also try to do those questions when you are free. And later answers actually already posted in our official website also. Okay, you can go to our official website, TTC Education there. There's actually a link you can find there. It says PDF notes and also PDF answer. Okay, so like soft copy answer and soft copy questions. Okay. So now the questions that we will be doing today, right, is actually starting from question number 2. We'll skip question number 1 because question number 1 is just a linear motion questions. Okay, very simple one, linear motion. But of course, later I will be doing some other linear motion questions. But just that because due to the time constraint, I will choose those that I think it's slightly harder one, so that the easy one you can do at home. Okay. So can you go to page number 7 and then you look at question number 2 here? Now, come, actually, I can suggest you all one thing. I think this thing I mentioned before in the normal class is that when you're doing a question, right, and especially when you're doing a revision, when you're doing exercise, now, when you look at the question, first thing you do, right, is to identify which subtopic the question come from, right? Which subtopic? Of course, you have to know which chapter and then also which subtopic from the chapter the question come from. So just like if you look at question on page number 7, this question number 2, right? If you look at this question first, you see a space vehicle and a space prop in the diagram, right? Before that, there is 2 diagram 4.1 and 4.2, right? So 4.1 is actually before the space vehicle and also the space prop before they dock with each other. So then afterwards, if you look at diagram 4.2, then it's the picture is actually the picture of the space vehicle and the space prop after they dock together, they connect to each other. So it's actually a collision question. If you still remember that time when we learned momentum, we also learned that momentum can be transferred through collision. So like when one object collides with another object, momentum will be transferred one. So for this one, I want you to write down so that you remember. It's actually a good habit that you write down. Like I said, you write down which subtopic the questions come from. So it's actually from the momentum questions and momentum subtopic. And in momentum, we learned that there are 3 types of collision. So this one in the diagram one is called the inelastic collision. So I'm not sure whether you remember how you recognize inelastic or elastic collision. Do you guys still remember? Now, for inelastic collision, right, we have to look at the question. You look at the diagram. Sometimes you read the questions also. If the question tells you, right, if 2 objects after they collide, they stick together one. So then this type of collision is what we call as inelastic collision. So of course, you can read the question first. Now, just like question tells you, question number 2, question says diagram 4.1 shows a space vehicle moving at 0.5 meter per second, about to dock with a space prop moving in the opposite directions. So over here, that's why I said you got 2 objects. Number 1 is the space vehicle. Now, space vehicle is the one that's supposed to carry the astronauts to the space. Of course, space vehicle usually can be the space shuttle. They will be carrying the astronauts, and of course, the rocket will be the one who carry the space vehicle into the space. So remember rocket, right? They will be carrying a space vehicle. And then when rocket go to the space, they will just leave the space vehicle in the space. Then the rocket will just fall back to the Earth one. So rocket is just a device, a transportation device that brings space vehicle into the space. So when space vehicle reach the space, right, the astronaut needs some place to stay. So they need a place to stay. So usually they will stay in space station, or sometimes they will stay in space prop. So space prop is basically their experiment lab. They do experiments in the space, right? Astronauts. So that's why over here you got 2 objects here. One is the space vehicle that carries the astronaut. Another one is the living space for the astronaut, the space props. Okay, they stay at space prop stays at the space all the time one. Okay, now so then if you look at this question, then question says at first the space vehicle that carries the astronauts will be moving at 0.5 meter per second, and then moving towards the space prop. So because they need to dock with each other, dock means they connect lah. So they need to connect with each other so that the astronauts from the space vehicle can go into the space prop. So of course the question also tells you that the space prop, now I use another color lah. Whatever information related to space prop, I use another color. I use pink color lah. Okay, more obvious. So red color one, I highlight the information for space vehicle. Pink color highlight, I highlight the information for the space prop. So question tells you that the space prop, right, is moving in the opposite directions one. So that's why in the diagram, you can also see the arrow that shows the space vehicle moving directions, right, is towards the right. While the space prop will be moving in the opposite directions to the left side. Yeah, then the question also tells you that the mass of the space vehicle is about 2,500 kilogram, while the space prop is 1,500 kilogram, because the question used the word respectively. So if you see the word respectively means because they will tell you two things, like for example, space vehicle and space prop. And then they say the question tells you that they are 2,500. That means this one refers to the first one. The second mass refers to the second object. So that's the meaning of respectively. Yeah. Then question also tells you after docking procedure, that means after they connect, the space vehicle and the space prop move together at 0.2 meter per second. Over here, they move together at 0.2 meter per second. Some more, the question also tells you the direction of the 0.2 meter per second is the same direction as how the space vehicle moved at first. So that's why you can see the arrow here. 0.2, some more, it shows you the arrow is going to the right. That means same direction as the space vehicle original directions. Then space vehicle was moving to the right side at first one. So also after they connect together, they will also be moving together to right side. Yeah, so that's why question A asks, what is the collision that occurs in diagram 4.2? So because they move together, so look at the keyword and also look at the diagram. It's because the space prop and the space vehicle, they move together. Okay, space vehicle and space prop. Okay, these two. Now they move together, so that's why we know it is a inelastic collision. Is that clear? Remember, now if these two objects after they collide, they don't move together one, that type of collision is called elastic collision. Clear? Now, then the next one. So B, then question asks you, based on the information provided, you have to calculate the total momentum of the system. So how do you calculate total momentum? Now, total momentum means you have to add. Now, the word total means you have to sum. You have to add everything together. Right now, that's the word. That's the meaning of the word total. So, what do you have to add? You have to add the momentum of the space vehicle and also the space prop. But there are two diagrams. Right now, in the diagram, there are two diagrams. Diagram 4.1 and diagram 4.2. So, which momentum? Are we going to add the momentum of the space vehicle and also the momentum of the space prop before they collide? Or do we add the momentum of the space vehicle and the momentum of the space prop together after they collide? So like which one? So it should be both also can. Now you need to remember that's because right in chapter 2, that time when we learned momentum, Newton also suggested that, okay, the Sir Isaac Newton, okay, the great scientist, the great physicist, he mentioned that actually, right, when you add the momentum of the space vehicle and also, okay, we call it object number 1 now. So if let's say I assume that space vehicle is the object number 1, while space prop is the object number 2. So if you go and add the momentum of the space vehicle and also the space prop, object number 1 and object number 2, add together their momentum before they collide, right? And also after they collide, these two amounts, right, they are actually the same one. That means again, momentum of object number 1 plus the momentum of object number 2 before they collide is actually equals to the total momentum of object number 1 plus object number 2 is actually the same one. So momentum is always conserved. So that's why, right, you can actually also skip to question number 3, then B3. That question asks you to state and explain the principle that you will be using in your calculations. So just now, right, because question says when you're calculating your questions number B2, what principle and also what is the meaning of the principle that you use in calculation part 2. So this is because, I mean, you have to remember how this thing is called what? Conservation of the momentum. Okay, oh sorry, it's called the principle. It's a principle of conservation of momentum. Principle means rule. So you are using this rule to calculate the answer in part B1 and part B2. Yeah, you are using this rule. All right. And what does this rule state? So you just have to explain. It states that, remember, what does it say? Do you remember? So it says the total momentum of two objects before and after collision. So total means, let's say object number one, object number two, before they collide, you go and calculate their momentum and add them together. It will be equal to object number one and object number two. Their momentum after they collide, add together, is supposed to be the same one. So before and after, see, total momentum of two objects before and after collision is conserved. Conserved means equal. That means it will not change. But of course, it comes with a condition, provided if what? Provided if there's no external force acting upon the system. Now, when we use the word system, right? System means the situations. That means it can be anything, like two balls hitting each other. Let's say a bowling ball hitting the pin, a car hitting another car. So it can be anything. So system means the situations, right? So in this question, the system is two objects. One is the space vehicle, another one is the space prop. Okay. So that will be the rule, the name of the principle. So principle means rule, the principle that we will be using to calculate the answer in part B1 and part B2, to do the calculations. Okay, clear? Now, so back to the question B1, then question, like I said, question was asking you to calculate the total momentum. Like I said, you can calculate the total momentum of the space prop and the space vehicle before they collide and also after they collide, whichever you like. Now, so how do you calculate total momentum? But of course, first thing, how do you calculate momentum? If you remember, right, momentum is calculated by using, now, of course, this one you have to remember yourself, this one. You have to remember this formula. Very simple one. Momentum, you can just calculate momentum by using mass multiplied by velocity. But yeah, the symbol that we should use for velocity, right, is supposed to be a letter V. But now I use letter U, it's because U means the initial velocity. So like I said just now, I assume that the space vehicle is object number one. And object number two, I assume it to be the space prop. So then this one, if you want to find the initial momentum of the space vehicle, just use M1 multiplied by U1. Right now, mass of the space vehicle multiplied by the initial velocity of the space vehicle. Because like I said, code one means, the symbol number one means it is actually referring to the space vehicle. We assume it to be the space vehicle. Clear? And then, like I said, if you also want to calculate the momentum of the space prop, like I said, we assume space prop to be the object number two. So it will be M2, right? Not? So M2 what? M2 multiplied by U2, multiplied by the initial velocity of the space prop. And again, because we want to find total, how do you find total? Just add them together, right? So if you use the total momentum, the initial momentum of the object number one, which is the space vehicle, and then multiply and add together with the momentum of the space prop, you will get the total momentum of the system. But of course, like I said, this is one method. There's actually another method one. So another method is also, you can also calculate the momentum of the space vehicle after they collide. Just now, we were calculating this one. This one is actually the momentum, the total momentum of the space prop and also the space vehicle before they collide, because that's why we are using the initial velocity. But of course, you can also use, like I said, you can also use the final momentum. That means the momentum after these two objects collide. So you can use the momentum of the space vehicle. Sorry, the first object is space vehicle, correct? Okay, first object is the space vehicle. And then also calculate the momentum of the space prop, M2, V2. Right? I'm using V now because V means final velocity, which is the velocity after they collide. So, and you sum them together, right? It will also give you the same value as you calculate this one. So these two values, when you add them together, they are supposed to be the same one. Like I said, that's the meaning of principle of conservation of momentum. That's what Newton trying to tell you. The momentum before they collide, you add together, and the momentum after they collide, you add together, they will be the same one. So we use this equal sign to represent same. Right now, same means equal. So that's why we put the equal sign in between. So which one should we use to calculate the total momentum of the system? Very simple. Just choose whichever. Of course, there will be only one answer. But how do you know which one to use? You can do try and error. You can try the first one first. But I can tell you, if you try the first one, it won't work. You cannot find the answer one because you don't have the initial velocity. This one. You too, you don't know. You don't know what is the initial velocity of the space prop before the space prop connects with the space vehicle. See, you look at the question. This one, what is the initial velocity of the space prop? Don't know, right? This one, you too lah. Initial velocity of the object number 2, which will refer to the space prop. Don't know. So if you don't know, then you cannot use the first formula lah, right? But you can use the second formula. So of course, if I want to find the total momentum, by the way, do you guys still remember what is the symbol that we used to, the symbol for momentum? The symbol that we use to represent momentum, that is this a letter that looks like a P, but it's not P. This thing is actually rho. It's actually a letter R in Greek word. Doesn't matter, okay, just to remind you, okay, it's actually the symbol we use for momentum. Now, and okay, by the way, do you guys still remember this formula, right? It's actually the elastic collision formula. This one is the elastic one. But like I told you also, inelastic and also explosion collision formula, they are all from elastic collision formula one. So that means that if today, right, because now we know the question, right, is actually a inelastic collision. The collision that happens in the question is an inelastic collision. So if you want to find the inelastic collision formula, you can also use the elastic collision formula and derive. You derive the elastic collision formula and make it become inelastic collision formula. So how do you do that? Very simple one. Now, if you still remember, just now we discussed that after this space prop and also the space vehicle, after they dock with each other, that means after they connect with each other, right? They will be moving together. And what does moving together means? You have to remember, moving together means their speed will be the same. That means V1 will be equals to V2. The speed of the space prop and also the speed of the space vehicle after they dock, that means after they connect, they will be moving together. So can I say V1 equals to V2? Obviously can, right? And so what will you do? Now, very simple one. See, if V1 and V2 is the same, then you don't need to use the 1 and 2. Now, we use V1 and V2 to differentiate them. Right now, the reason why we put 1 and 2 is because we want to differentiate the speed. But if let's say these two speed is the same, then we don't need to use the 1 and 2 anymore. We just put V. And if let's say, see, these two terms has same factor. These two terms have the same factor, then what can you do? Now, this one you learned in mathematics before one. If you have two terms that has the same factor, you can factorize the factor out. Right now, because the M1 multiplied by V, M2 also multiplied by V. So you can take out the V and make it as a common factor. You factorize it out. Okay? Yeah, so then that means what? That means if you want to calculate the total momentum of the system, and now, like I said, we are using the momentum after the two objects collide, after the space vehicle and the space prop, after they connect. Right now, after they connect, we are using that method to calculate the final, the total momentum. And in this case, right, we only need three quantities. See, you only need M1, M2, and also the velocity. That means the common velocity of these two objects. So just go and find from the question. Very simple one. Just now remember, the question did tell you that the space vehicle is 2,500 kilogram, while the space prop is 1,500 kilogram. And then the common velocity after they connect and they move together, if you read the question, then this one, after they connect, they will be moving together at 0.2 meter per second. So the V will be 0.2. Right or not? Then the V will be 0.2, the common velocity. Why my hands merge one? Okay, this one, 0.2. And the value we use, right, should be a positive value because the object is going in the positive directions. Right now, that's just now I said, if you put 0.5, and if you assume this as the positive directions, this one would be a negative directions. Your U2 will be negative directions. And can you see the speed after they connect and they move together, that speed, right, is actually the same direction as how the space vehicle originally moved. So it will be a positive value. So just put 0.2. So, and if you sum the value and then multiply the 0.2, you will get 4,000 multiplied by 0.2. So 4,000 multiplied by 0.2 should give you 800. Okay? Now, so that means that's the total momentum of these two objects after they combine, after they connect. But like I said, it's also equals to the total momentum before they collide. Okay, because it's supposed to be the same one. And also, you have to remember, right? 800. You cannot just write 800. You have to write the answer with units. Okay, you have to provide your answer with units one. So remember, for momentum is a very simple one. For momentum, if you want to find the unit, very simple, just go and see the formula. Now, I told you many times, if you want to find the units, go and find the formula. And from the formula, right, you can derive the unit out for yourself one. Like for example, now because we know momentum is calculated by using mass multiplied by velocity. Am I right? And so just go and recall what are the units for the mass and also velocity. So for mass, right, we use kg as the SI unit to measure mass. And for velocity, we use meter per second as the SI unit. So all this you have to remember, these are the basic ones. But of course, if you get to remember these two, you just have to combine them together. Now, see, mass uses kg, velocity uses meter per second, right? So, and to calculate momentum, you're using mass multiplied by velocity. So just combine these two units together and it will become the unit of momentum. Clear? So 800 kg meter per second. Yeah, like this. 800 kilogram meter per second. So that is the unit we use to calculate momentum. Clear? So that's the answer, like 800 kilogram per meter, 800 kilogram meter per second for the answer for momentum. Okay, then the next one. So B2, right? Then the question asks you, then calculate the speed of the space prop before docking with the space vehicle. So speed of the space prop and also someone is before docking the space prop with the space vehicle. So means you are calculating this speed lah. So how do you calculate this speed? Very simple one. Then remember this formula. Just now we have the U2 in this formula, right? U2, like I said, we assume that object number 2 is the space prop. So you are asked to calculate this U2. U2, like I said, code number 2, 2 means space prop. We assume 2 means space prop. So, but we don't have to calculate the M1 and B1 add the M2 multiplied by B2 already, because you already know after summing up together, they should be 800. They add together, after adding them up together, they'll be 800. And so that means what? That M1U1 plus M2U2 add together, it should be 800 also. So this is what you do. Your M1, just put in, just follow how you assume all the information. Remember just now we discussed that 1 is the space vehicle. So space vehicle, according to the question, is 2,500 kilogram, right? You have to get it right now, this one. Your assumption, you have to make it right, because you have to use the right mass multiply with the respective velocity. So just now the question did tell us that the space vehicle, the object number 1, space vehicle, is at first moving at 0.5 meter per second. Then at wave, the momentum of the space prop. Right now, space prop is 1,500 kilogram. So, but we do not know the speed of the space prop. That's what the question wants you to find. So whatever your unknown, right, you have to leave it as back as the unit, back as the symbol. So if you're looking for U2, then just leave U2 as U2. Okay, you're looking for 2. 2 means space prop. Like I said, we assume object number 2 to be the space prop. So U2 will be the only unknown in your calculations. Then just calculate, then you get the answer one. Yeah, so you should be getting a value of this one, 1,250. Then everything the same. Okay, afterwards, then everything the same. Just after if you calculate 2,500 multiplied by 0.5, it'll be 1,250. Then just do your algebra expression, everything. Let's see, 800. Just now, this one, 1,250 is you add 1,500 to the another momentum. So what you do now, is you move this positive value to the other side of the equation, and then it will become minus lah. It will become negative because that was a positive value just now. Before you move it to the other side, it was a positive value. So after moving, then it will become a negative value, right? So it will be 1,500 times of U2 equals to 800 minus 1,250. So 800 minus 1,250, you will get negative 450. So 1,500 times of U2 equals to negative 450. So U2 will be same thing lah, algebra expression. It will be negative 450 divided by 1,500. Press your calculator and your answer should be negative 0.3 meter per second. So you should be getting a negative answer. Okay, you should be getting a negative answer. So don't worry if you get a negative answer. It's totally fine. And let me explain to you why. Because like I said, if you look at the diagram, space prop is originally moving to the opposite direction of the space vehicle. And remember just now, we assume that going to the right side, that means the direction of the space vehicle as the positive directions. So that means, right, when space prop is moving in the opposite directions, then space prop will be the negative, will be the negative direction. So that's why the speed, your velocity, you will get negative value. So that negative in the velocity means the object is moving in opposite directions. Okay, so it's totally fine one, and it's correct. You should be getting a negative answer. Okay, so that's your answer. Huh? So that's the speed, the velocity of the space prop before docking with the space vehicle. Clear? Yeah. So after that, then let us move on to question C. And now I'll just keep on be teaching now, okay? So if you guys have any question, just ask. If not, I'll just keep on be teaching. Yep. Then the next one, question C. Now we've done the question B part 3 already, right? So we go to question C. Question C, then question ask, describe the propulsion of the rocket in terms of momentum. So that means question wants you to use momentum and to explain how rocket propel. Propel means launch. So how rocket is launched to the space. So for this one, it will be a 4 marks question. So very simple one. You have to think how rocket is being propelled. Just imagine. Okay, you can close your eyes and then you think how rocket is being propelled, is being launched into the space one. So before launching, right? I'm sure sometimes you see you watch some video, right? Rocket before they launch, they will expel a lot of exhaust gas at the bottom one, right? So yes, that's what they do. They will need to expel a lot of exhaust gas downward to create downward momentum. And so because according to what Newton told us, according to principle of conservation of momentum, when you create a downward momentum, you will also be getting an opposite upward momentum. So then that upward momentum will drive the rocket up. So that's how rocket launch. Yeah, but of course you have to, for this one, right, you have to leave 1 mark because it's a 4 mark question. So for the first mark, right, you have to explain how the gas is produced, how the exhaust gas, the expelled gas is being produced. So first, right, those hot gases actually they come from the combustions of the fuel. So in the combustion chamber of the rocket. So in rocket, the place that combusts fuel is called combustion chamber. In car also the same one. In our car, there's this part in front of the car called engine. So inside engine, there's this part called combustion chamber that is used to burn fuel. Okay, so first thing you write, right, is you explain how those hot gases come from. Okay, where does the hot gases come from? So this one, you write when the fuel mix with the oxygen and also combust. First thing, they will be combust in the combustion chamber of the rocket. Combustion chamber in the rocket, or you can also write of the rocket. So oxygen mixed with the fuel. So that's how it combusts. Okay, because when combustion occurs, you need oxygen. So then, of course, the next thing you write, right, is this thing called explosion. Now, the explosion is not the bomb explosion. This explosion is the momentum collision explosion. Remember that time I said just now we discussed, last time also we discussed collision. There are 3 types of collision: inelastic, elastic collision, and then also explosion. It's one type of the collision. Okay, one type of collision. So explosion. Now, like I said, the collision we refers to is the type of collision we call it explosion. So an explosion occurs, then happens what? And it will produce, okay, hot exhaust gas. downward at the bottom of the rocket. Yeah. So this is the first thing you have to write. You have to give an introduction before you explain everything. Yeah. Then now once you get the hot gases expelled downward, what happens? Now you continue to explain now. Give more details about the hot gases being expelled downward. So you can write a large amount. Large amount means large masses. The mass of the hot gases are big one. Big masses, large amount of hot gases. Okay, they are being expelled downwards. Right now, of course, you can write exhaust gas now. Exhaust gas will be better because it's the gas that you expel. Okay, large amount of hot exhaust gases is expelled downward. Right now, it's being expelled downward. And of course, you explain, are they fast or are they slow? At high velocity, they should be expelled at a very fast speed, and so it will produce a large downward momentum. And of course, don't rush your answer. Don't just write after producing large downward momentum, then you get the upward momentum for the rocket. Then the rocket will drive upwards. Now, before you tell the question that the rocket will be getting the upward momentum, you can also explain a bit of the principle. So explain a bit of the principle, touch a bit, discuss a bit about how you get the upward momentum. So discuss a bit, just a bit. You don't have to explain the everything one. Not like just now how you explain in part B3 just now. So let me show you how. Just write according. So you are like pushing the blame. You are like telling your teacher, right? This thing, right? It's not I say one. This thing is what Newton say one. Newton say like our principle, according to this principle of conservation of momentum, stated by Newton. So he says that if downward momentum is produced, then there will be this upward momentum. So then this one. So according to the principle conservation of momentum, okay, sorry, this one, of the momentum, then you explain a bit, just a bit. No need to explain everything one. So how do you explain? Say total momentum in the system is conserved. Use the word conserve lah. Conserve means equal. Just now we discussed. Okay, or you can also use the word is always conserved. That means all the time, all the momentum is conserved one. So if you get an upward momentum, you will also be getting a downward momentum. So they should be equal one. Okay, according to Newton's third law. Actually, according to Newton's third law one. Okay, Newton's third law of motion. So then lastly, only you tell lah. Okay, lastly you tell, therefore, what happens? The rocket will propel, or you can use the word launch upwards as it gained the upward momentum from the downward momentum, right? Because the downward momentum produced, and according to Newton, when you produce downward momentum, when an object produces a downward momentum, the object will also be gaining an upward momentum. So then, of course, also you can explain how what is the characteristic of the upward momentum. Then you can say it gain an upward momentum that is equal but opposite to the downward momentum. So that's how the upward momentum is produced. It's from the downward momentum, and the amount of upward momentum is equal, but just opposite to the downward momentum. Okay? So very simple one. Just go home and read through, and then so that you know how to answer in your exam. You must know how to write. I mean, you must know what to write. Then only you know how to write. Okay, you remember those keywords first. First thing, you have to explain the fuel being combust. So try more writing. I mean, try writing another one more time on your own, and then that's how you practice lah. Okay, that's a suggestion I can give you. And then remember producing a downward momentum. So that's the second thing you have to talk about. Third thing that you have to discuss about is the principle lah. So the principle of conservation momentum. Lastly, say that the upward momentum. Discuss about the upward momentum that comes from the downward momentum. Is that clear? So and after question C, you look at question D. Question D is an essay question. Then this essay question asks, the diagram below shows a water rocket made by a student. So you are required to give some suggestions on how to modify the water rocket so that it can travel at the maximum horizontal distance. Using the knowledge on the forces, motion, and the properties of the materials, state and explain the modifications based on the following aspect. First thing, question wants you to discuss about the material used for the water rocket. Now over here, right, remember this answering table in the essay, in the exam questions, right? Your teacher won't be giving you this answering table one, so we are just saving up your time so that you don't have to write your own table. You don't have to draw your own table now. But remember, in exam, you have to draw your own table one. So we are also letting you to familiarize, to get you familiar with how to draw the table. Yeah, so this one, the next thing on the top right corner, you write reasons, because you have to give reason for every characteristic you choose for the water rocket. First thing, now material used. Remember, there are two things you can write, because now this question, right, is quite open, because the question never tell whether it is what characteristic about the material. It can be the density, it can be the strength. So whichever you like lah, okay. I think you can write density also, but for me, I will write high strength material. I will go with the strength lah. It's because, right, do you guys know how water rocket works? Now, water rocket, you have to fill the water bottle with water, then they will pump gas into the water bottle. So the gas will be compressed at high pressure. So when the water is expelled out from the water bottle, at high pressure and also high speed, it produces a downward momentum. So the water that expelled out will produce the downward momentum. And according to what we discussed just now, when the water is being expelled downward, producing downward momentum, the water bottle will also gain an upward momentum. Yes, so that's why the water filled inside the bottle, right, will be pumped. That will be applied with a high pressure one. So, and of course, the reason why I say I want to go with a high strength material of the bottle, right, is because if the bottle is weak, and then when you pump pressure into the water bottle, if the water bottle is not able to withstand the high pressure, then the water bottle will break. Right now, it will burst. So that's why the strength of the material of the bottle has to be high strength. So high strength material of bottle. Of course, like I said, you can also write low density, because low density means it will be lighter. Lighter means it will be traveling faster. Yeah, because also if you read the question, right, the question did say what you want for the rocket. It's at the second paragraph. If you read the question says that you are required to give some suggestions on how to modify the water rocket so that it can travel for maximum horizontal distance. So your objective here is to make this water rocket to travel the furthest horizontal distance. Horizontal means the left to right distance. Okay, the up and down distance, that one is called vertical distance. So now we don't want the rocket to travel vertically up. We only want the rocket to travel maximum horizontal distance. So later on, right, if you look at the third modification, the question also asks you to modify how you want to launch the rocket. The rocket, not the rocket, the rocket. How you want to launch the rocket. At what angle? So later we will discuss about that. Okay, but this one, high strength material of the bottle, we'll come back to this one. So for the first choice just now, for the material, we want it to be high strength. But why high strength? Because high strength, so it can prevent the bottle from breaking, right? Now, to prevent the bottle, or you can also using the word bursting. So from bursting. Yeah. So when high gas pressure, because like I said, you have to pump high gas pressure into the bottle one. So when high gas pressure is applied into the bottle, so then the bottle won't break easily if the material of the bottle is high strength one. Okay, so then the next one, second one, question asks you to give modifications for the shape of the rocket. So for the shape of the rocket, I know sometimes, right, when you buy the bottle, you cannot choose one. Like for example, if you're using this bottle, then you cannot choose one. Of course, if you get to choose the shape of the rocket, of the bottle, try to make it more aerodynamically. So that means sharp lah, like this one. Actually, this is quite aerodynamic. That means it has to be sharp. Why sharp? Now, we don't use the word sharp lah. Okay, just to explain to you, aerodynamic means sharp. But why it has to be sharp? Because it will cut through the air resistance even better. So when it cuts through the air resistance will be reduced. So when air resistance reduces, the water rocket will be able to travel further distance. The greater the air resistance, the shorter the distance traveled by the bottle. Okay, traveled by the water rocket. So like I said, don't use the word short, just write aerodynamic. You have to learn this word. So the shape of the bottle, it also applies to cars, to aeroplanes, to ship. But for ship, right, for boat and ships, we will use the word streamline. So instead of using aerodynamic, we will use streamline. Okay, so it's also the same reason. So instead of reducing the air resistance for boat, we want the shape to be streamlined because we want to reduce the water resistance. So if the object is moving in the air, we'll reduce the air resistance. If the water is moving in the, if the object is moving in the water, then we'll reduce the water resistance. Okay, so aerodynamic shape of the bottle. So just to let you all know, because I won't know what exam questions will ask you, what your school exam question will be asking you. So just to let you all know, so remember for ship, then you write streamline shape. But for let's say cars, aeroplanes, rocket, we use this word called aerodynamic. Okay, for the shape of theirs, to reduce the air resistance. Okay, so the main objective, like I said, to reduce air resistance. Yeah, to reduce air resistance acting on the water rocket. So that's the reason why you choose it to be aerodynamic shape. Clear? Then the next one. So the third one, right? The question is asking you, how do you want to launch the water rocket, the water bottle? So the angle, at what degree? Now, do you guys know, if you launch the rocket horizontally like this, the rocket will not travel the furthest horizontal distance one. Because if you launch your rocket like this horizontally, the thing is, if you do this, your rocket will fall to the ground very, very quickly. Okay, they will reach the ground very quickly. See, imagine if you launch the rocket horizontally like that, and this is the floor, it will reach the floor very quickly, because launching horizontally means it will be very close to the ground, right or not? So that's why, right, you cannot just launch the rocket like this flat 0 degree. 0 degree flat, that means parallel to the ground. Cannot one. It will be reaching the ground even faster. So the most efficient way, right? Actually, this is a fun fact. I'm not sure whether you guys know or not. Actually, you have to launch the rocket at 45 degree one. 45 degree will make the rocket to travel the furthest horizontal distance, the maximum horizontal distance. It's because this 45 degree, right? I'm not sure whether you guys know also. 45 degree actually very simple to find one. 45 degree is actually just in between a vertical line and a horizontal line. See, if you draw a vertical line, up and down line, and then after you draw a horizontal line, left to right line, and then in between, because in between a straight line and the horizontal line, it should be 90 degree. So if you cut through in the middle between the 90 degree, then it will be 45 degree, right? Not? And then at this 45 degree, right, it will make the water rocket to travel the furthest, like I said, the maximum horizontal distance one. Because the rocket is going up at the same time going to the horizontal distance, going to the right side, let's say. So going horizontally at the same time also going vertically up. So it will not go to the ground. It will not touches the ground so quickly because it is going up at the same time going to the horizontal distance. So that's why there's a sport called javelin, and also lontar peluru, right? Not the shot put. All these sports, right? When you throw the shot put and also the javelin in the track and field events, in the school, if you go and train, right, your coach will tell you to throw javelin at 45 degree one, because when you throw the javelin at 45 degree, that is when the javelin can travel the furthest horizontal distance. So if you throw it horizontally like this, right, it will not travel the furthest one, in fact, because like I said, it will reach the ground even faster compared to you launching the javelin or the rocket 45 degree. Okay, so this one, remember, it's actually a fun fact that you need to know, because if you don't know, and yeah, I know, a lot of times, right, students will always tell me that if you see this question in the exam, you don't know how to do one. Right, a lot of times, do you have this point? I mean, do you have this thought that if you see this question in the exam, right, you will thought that you don't know how to do one, and it's actually totally normal, because That's the reason why we do exercise together now. We discuss. So if you do this question before, if you did it before, and then later on you go into exam, right? You will know how to do better lah. Okay. So for this one, just write 45 degree. Remember to write the unit degree. Yeah, so 45 degree angle of launching. So when you launch the water rocket, you want to launch it at 45 degree. And again, it's because you want to maximize the horizontal distance of the water rocket. So this one, to maximize the horizontal distance of the water rocket. Okay, clear? Now, next one. Now, next one also, if you know, you will know one. It's also like the third one, 45 degree. If you don't know, you will just go and, hantam a bit. You just simply hantam an angle one. But if you know that the angle should be 45 degree, then you will know. But of course, you will know provided if you did this question before or someone told you before. If you don't know, if you forgot, if you never see before, you won't know one. Okay, very hard to hantam until the right answer one. Okay, so like the fourth one also actually. So question is asking you, right, the volume of the water in the rocket. So can you think how much of water should we fill in the rocket? Should we fill the water to the entire bottle or not? Like 100% of the bottle? Or how many percent of water should we fill in the rocket? Do you guys know? This one also, actually, according to studies, right, filling the water into the rocket, 1/3 of the volume of the rocket is actually the best ratio. Because you cannot make the water bottle, right, to fill with fully water one. If it's filled with fully water, it will be too heavy for it to launch. But it cannot be too little also. So which one is the best ratio? Now, the best ratio is actually 1/3. So this one, now 1/3 of, so you write down a fractions, 1/3. Okay, 1/3 of what? 1/3 of 1/3 volume of water. So it's a ratio one. So that's why you say no to what? To the volume of the bottle. So that means when you fill the water into the bottle, fill it 1/3 ratio of water into the bottle. Now, why? Like I said, because you don't want it to be too heavy so that it can launch more easily. So to reduce your answer, your reason to your choice should be to reduce the mass of the rocket and enable the rocket to launch more easily. Like I said, if it's too heavy, it will be very hard for the rocket to launch. Clear? Now, then the next one. Now, the last one, right? The question asks you additional structure. So if you look at the questions diagram, the diagram also shows you that the structure is actually this thing here. Do you know what we call these things? It's just like how you call this thing on fish. We call them fins. I'll call them fins, okay? So those things are fins. Now, do you guys know what is the function of fins? Fins, right, is actually for the rocket to launch more stably, right? To be more stable, okay? The launching of the rocket to be more stable because when the water is expelled from the water rocket, the water will be traveling left and right one. So when water is being expelled left and right, the launching of the rocket, right, will also be shaking one. Okay, it will vibrate, and then also the track of how the rocket launch, right, will be a bit off one. So that's why with the fin, it will stabilize the launch of the rocket. Okay, the launch and also the propulsion of the rocket will be more stable. Also, we can use the word smooth. It will be smoother and the stability will be increased. Okay, so for this one, the additional feature for this one, we will put this one, right? Okay, that's my, hold on, I think my Apple Pen is out of battery already. Let me check. No, it's not. Okay, hold on. I think my iPad is just not responding. Now this one, okay, come back already. Okay, this one, just write install. You write install fins at the tail of the rocket, or you can also use the word bottom So at the bottom of the water rocket, okay, of the water rocket. Okay, tail means bottom at the downside of the rocket. Yeah. So and why? Like I said, it's because you want to increase the stability and also the smoothness Okay, smoothness of what? Of the rocket launching and also propulsion. Okay, we can write now. Of the propulsion of rocket, propulsion of the rocket launching. So that means including the launch and also the propulsion afterwards, it will be more stable. Is that clear? So this is a very long questions lah. So that's why we take so much of time. Yeah, very, very long questions. Okay, including calculations, explanations, and an essay. Yeah. Then after that, let us move on to question number 3. Do you guys need a break? If you guys don't need a break, then we'll just continue lah. Okay. Okay lah. For those who need breaks, then you just go. I'll just continue be teaching because I don't think I need break lah. Okay, I'll just continue be teaching. Yeah. So you look at question number 3. So for question number 3, right? Then this question, you look at the diagram first. So if you look at the diagram, right, there is this thing is called swing, right? There are 2 persons playing on the swing. So swinging on the swing. So one is the child, another one is the parents, I guess, right? The adult also on the swing, swinging on the swing. So that's why the question also tells you. Question number 3 says a child and an adult sit on a similar swing as shown in the diagram 2. So these two, they are similar swing. Just one is an adult, another one is a child, right? So do you guys know what question is? I mean, what subtopic does this question belongs to? This one is actually, of course, chapter 2. But in chapter 2, which subtopic? Now, do you still remember this thing we learned for Newton's first law of motion? So that's why if you look at the question 3a, question also asks you to explain Newton's first law of motion. It's related to inertia one. Do you still remember what is inertia? Inertia means the tendency of an object remaining at their original motion. So it's like if an object is at rest, the object will tends to be at rest. They want to be at rest. And when the object starts to move, right, the object will want to continue moving. So they tend to keep at their original motion. Like I said, if an object remains at rest, the object will want to remain at rest. And then if the object is moving, then the object will want to continue moving one. So that's the tendency. Okay. So the feeling of the object wanted to continue moving. That one is called inertia. Right? So 3a question asked, state Newton's first law of motion. So it's actually related to inertia. Like I said, that's the things that I explained just now. Okay. So right now, Newton's first law of motion states that the object will remain at rest. That means object that is at rest, right? They will try to remain at rest. So obviously, and then or what? Or it will remain, the object will remain what? Constant velocity. So that means if an object is moving with constant velocity, the object will also, the object will want to continue moving with constant velocity in the same directions. But of course, this comes with a criteria. It comes with condition. Unless what? It comes with a condition one. So the condition is unless everything works unless acted upon by an external force. That means when this object, okay, is acted by another force, then of course this object will not follow this rule anymore. The law. Okay, the law means the one I explained to you just now. When an object is at rest, the object will want to be at rest. That of course, if you don't move the object won't move. But of course, if you go and push it, then the object will move. So when you apply an external force, the object will disobey the law. Okay. Now, then the next one. So if you look at question B, then question asked, if they are given the same push, that means if you apply the same force to the child and also to the adult, who is more difficult to move? The first one. Which one do you think? Is it the child or the adult will be harder to move when you push it with the same force? When you push them with the same force? The adult. Try not. The adult will be harder to push. Why? Because the adult is heavier. All right. So when the adult is at rest, right now, at rest at first, but if you want to push it, it will be harder to push because, like I said, when the mass of the object increases, it will be harder to move. Same thing. Do you know that if the object is harder to move, the object will also be harder to stop? It will be more difficult to stop. When the object is moving, so it will continue moving. It will want to continue move. But if you want to stop it, it will be harder to stop also at the same time because of the inertia of the object. Okay, so remember, mass affects inertia. The greater the mass, the greater the inertia of the object. Clear? Now, so then you explain. Then the third question is asking you to explain why do you say in part 1 and also part 2, why do you say that the adult is harder to move and also harder to stop? It's because that the mass of the adult is greater than the child, or you can use the word large lah, larger mass. The adult, sorry, this one, adult has a greater mass than the child. So what? So the effect of inertia of the adult will be greater, and the effect of inertia will be greater. Sorry, the effect of inertia of the adult will be greater than the child. So when the inertia is greater, that means it is harder to stop and also at the same time harder to start moving. Okay. So that's the answer. Then the next question, question C, then ask, in diagram 1.1 and diagram 1.2 shows two hacksaw blades of the same length with the plasticine ball of different mass attached to their ends. So can you see in these two diagrams, you see there are two hacksaw blades, and in these two hacksaw blades, on top of the hacksaw blade, we will stick a plasticine ball at the end of the hacksaw blade. But these two examples and these two directions, these two experiments, what is different in these two experiments? Now in diagram 1.1, right, can you see the plasticine ball is 50 grams? That's the difference. And then in diagram 1.2, the mass of the plasticine ball is 200 grams. Right now, so one experiment, we are using a lighter plasticine ball. Another one, we are using a heavier plasticine ball. Okay. Now, and then, right, for the oscillations period, that means the time taken for the hacksaw blade to oscillate, the time taken, when the plasticine ball is 50 grams on the hacksaw blade, the time taken for the hacksaw blade to oscillate one time is 1 second. So that's the period. The time taken for oscillations, for one oscillation, yeah. And then for the plasticine ball that is 200 grams, for the hacksaw blade to oscillate one time, the time taken will be 2 seconds. So can you see? When the mass of the plasticine ball is heavier, it's actually harder for the hacksaw blade to oscillate. Because like I said, when the mass increase, inertia increase. So when inertia increase, right? Because you have to understand, oscillation means the hacksaw blade is oscillating left and right. So moving left and right means constantly the hacksaw blade is changing in directions. So when object with greater inertia, it will be harder for the object to change in direction. So that's why it will be taking a longer time for the hacksaw blade to oscillate when the mass of the plasticine ball is more heavy. Okay, so harder to change in directions for the heavier object. So that's why a question asked, when oscillated, the both hacksaw blade oscillates with different periods of oscillation as shown. So question number 1, tick at the correct answer. So below there's a statement. So the statement says the period of the oscillation is a scalar or vector quantity. So for this one we just discussed, right? I mean, like, not just okay. That time we discussed during January, during our holiday class. So scalar quantity means a quantity comes with magnitude. Magnitude means number. So whatever quantity that comes with a number is called scalar quantity. Now it has to be a quantity that gives number and just number, because the another one is called vector quantity. So we categorize quantity under vector quantity when it has magnitude, and so like I said, magnitude means value. It comes with a number and also direction one. So for those quantity that comes with direction and also value, those quantity we call them vector quantity. Now, so magnitude only one, then time, the period of oscillation. Let me ask you, does time come with direction? Time don't come with directions one. Time, let's say 2 seconds. 2 seconds means 2 seconds. That's the value. The 2 is the value. It don't comes with a directions one. So that's why the time will be a scalar quantity. Is that clear? Then question number 2. Question number 2, then question asked, based on diagram 1.1 and 1.2, contrast the mass of the two plasticine ball used. Contrast means compare. Contrast. So what does the question want you to contrast? The mass of the two plasticine ball used. This one, obviously, the plasticine ball in diagram 1.2 has a greater mass than in diagram 1.1. Right now, so this one, very simple answer. Just write mass of the plasticine ball. Just repeat the question. Mass of the plasticine ball in the diagram 1.2 is greater than in diagram 1.1. That's it. Okay, just repeat after whatever question asks you. Question asks you to contrast mass of the plasticine ball, then write mass of the plasticine ball. Next one, question number 3. Question number 3 then asks you to contrast, that means compare the period of oscillations, okay, for the hacksaw blade, So this one, just write again, like I said, just repeat after the question. Period of oscillation of the hacksaw blade. Okay, in diagram 1.2, this one also obviously you can look at the diagram because the question already told you in diagram 1.2, the hacksaw blade will be oscillating using 2 seconds for every oscillations. But in diagram 1.1, the oscillations of the hacksaw blade, it takes 1 second to complete one oscillations. So obviously in diagram 1.2, it will be longer than in diagram 1.1. Is that clear? Yeah, this one, 1.1. Now, then the next one, number 4. Now, for the fourth one, question asked, state the physics concept involved in the answer above. So the fourth one will be the inertia. Yeah, inertia is actually the same as the previous answer, as the previous question just now. That just now the 2 person on the swing, one adult, one a child. So it's because of the inertia, right? That's just now we explained already. It's because the adult has a greater inertia. So that's why harder to stop, harder to start moving also. Clear? Now, then the next one. For question D1, then question asked, the property in which body resists the change from its states of rest or motion is known as inertia. That's what we discussed just now. Okay. The property of an object resisting the change from its states of rest or the state of motion is called inertia. So that's why question asks you, based on your answer in B, question wants you to relate the relationship of inertia and mass. So obviously this one also discussed already. When the mass increase, the effect of inertia also increase. So very simple one, just write the greater the mass of the object, the greater the mass of the object, the greater the effect of inertia, the greater the effect of inertia. So it will be harder for the hacksaw blade to change in directions. That means vibrating, because vibrating means left and right moving. So it'll be harder for the hacksaw blade to oscillate left and right when the mass is greater. So that's why we'll be taking longer time. Clear? Now then the last one, D1. This one we discussed before one. D2, last time in that time in normal class, that time we discussed before. Question asked, why does a super tanker need to stop its engine over a distance about 3 kilometers before it can finally come to a stop? So super tanker means the shape, okay, extra large shape that carries oil. We call it super tanker. So they have to switch off their engine before they reach the port. About 3 kilometers before they reach the port, they have to switch off their engine. Why? Now this one very simple. Just say because super tanker, we use the word super means it is super heavy. So super tanker, just follow the question now, okay? So if the question used the word super tanker, use super tanker. If the question used oil tanker, use oil tanker. Yeah. So super tanker has, you don't have to use super large mass, just say the super tanker has large mass. Yeah. So and because it has large mass, so and it will have what? And it will have the large effect of inertia. Yeah. So inertia means, like I said, when this object starts to move, it will be very hard for it to stop. So and then you see that causes the super tanker to what? And because it has large effect of inertia, so that's why the super tanker cannot stop immediately. It's not like car. No, you know ships, right? They don't have brakes one. Unlike cars, if you want to brake, you just have to press onto the brake pedal and then the car will stop. It will slow down first. Of course, it can stop very quickly because the brake pads will be creating friction to the brake disc of the tire. So, but in ships, right, they don't have a brake one. So that's why they have to switch off. They have to calculate all sorts of calculations okay, including how heavy they are at the moment, how fast they are moving at the moment, and the wind directions. Everything has to include, and then calculate, and then they will calculate the distance where they should switch off their engine. So because they cannot stop immediately, and like I said, and because they cannot stop immediately, so that's why they have to switch off the engine and slow down slowly, right? Not the ship has to slow down slowly, okay, and then come to stop. So that's why they have to switch off the engine 3 kilometers before it can reach the port. Okay, so that would be your answer for this one. Okay, that's question D. Now then let us move on to the last one, the essay question, question E. Now question E is also related to inertia because the whole question will be related to inertia one. Yeah, so then question E asks, in diagram below shows a petrol tanker truck that is used to carry and transport oil. Okay, this thing, transport oil one. So question wants you to suggest safety design of the loaded truck to transport fuel safely. And so your answer should be based on the following aspects. So the question only gives you 4 aspects. Let us read one by one. First one, question wants you to choose, how do you want to design the compartment of the oil tanker truck? And then next thing, braking system. Third one, gaps between the trucks and the fuel tank. And then number 4, right? Number 4 and the 5th one is actually together because they want you to think who other features that makes this truck to become more safe. Okay, to make it more safe to transport the fuel safely. Yeah, so for this one, again, it's also an essay question. So essay question every time the same one. So on the top left, you write characteristics, and on the top right, you write reasons. So characteristics, and then on the top right, you write reasons. This one, reasons. First, okay, come. For the compartment of the lorry. Now, do you guys know, if you remember what I discussed with you, if let's say, right, this is the tank of the oil tanker truck, right? Not imagine, right, if let's say now this truck is moving forward. When the truck is moving forward, the fuel, the oil inside the oil tanker will also be moving forward together with the truck. But then the moment when the truck brakes, right, the oil inside the tank will continue to be moving forward. They will continue moving forward one, and then they will hit onto the wall of this tank. And then when all the oil hits onto the wall of this tank, it creates a force, and this force, right, will drive the lorry to move forward a bit more. So it's actually very dangerous because the lorry brakes because the lorry wants to stop. But if the oil continue to move forward and hits the wall and causes the lorry to move forward a bit more, right? Sometimes it can cause a massive accident, okay, massive injuries to other people. Okay, maybe this truck might be hitting another car in front, or maybe someone else in the front. So that's why, and again, this thing is actually effect of inertia because when the truck move forward, the oil inside the tank also move forward. But when the truck stops, or when the truck applies brake, the oil still continues to move forward because of the inertia of the oil. And then the oil hits the wall, creates a force, causing the lorry to move extra a bit forward. Very dangerous, right? Not? But that time we discussed before, to solve this problem, right, what do? We separate the tank into more number of compartments. So instead of just using one big compartment, but we will split the compartment into few compartments. That is because when you split the big tank into few compartments, right, the oil in that particular compartments, they will only be hitting their own wall. And by doing so, we will reduce the effect of inertia because you are actually distributing the mass of the oil into different compartments. So remember, when you distribute the mass nicely, it will also be able to reduce the effect of inertia one. Okay, so mass distribution is also one very important factor. Okay, other than mass lah. Okay, because we discussed mass greater, effect of inertia also become greater. But the way how you distribute the mass is also actually a factor. Just that it's not in the textbook. So you have to remember, but of course you don't have to explain or you have to distribute the mass. Just write for compartment of lorry, of the fuel tank, right? separate the fuel tank into more numbers of compartments. Separate what? The oil tank into more numbers of small compartments in the tank. So actually the volume of the oil carried by both situation, right? Just imagine, right? Imagine one big tank and one big tank separate into few small tanks. The amount of oil actually carried by the tank is the same, just that we distribute the mass. And like I said, if you distribute the mass nicely with the same mass, but you will still reduce the effect of inertia, and it will make the truck become less dangerous. Okay, because less inertia, then the truck can stop immediately. To stop in the shortest time and also shortest distance, so that the truck don't move forward anymore after it stopped. Okay, so this one it's all because of to reduce the effect of inertia. So to reduce the effect of inertia of the oil tanker truck of the truck. Clear? Then the next one, number two. Number two, braking system. Now, this one we also discussed before. For braking system for all on the road vehicle. Okay, that means it can be lorry, it can be van, it can be truck, it can be cars, it can be motorcycle. For braking system for vehicles on the road, we will ask. we will not ask now. Okay, they will always install the car manufacturer, all these vehicle manufacturer, right? They will put this thing called ABS one. Okay, so ensure that the truck has what? The truck has this thing called anti-lock braking system. So do you guys know like how car stops? How vehicles with tire stops? You guys can call it ABS, but remember, don't just write ABS. Before you write ABS, right, you have to write the full name of ABS. You have to write anti-lock braking system ABS. Okay, so remember, of course, just now I asked you, right? How do you guys know how car stops? Car stops because when you apply pressure onto the brake pedals, the brake pedals will transfer the pressure and lock the car tires. So when the car tires don't rotate, then that's how car stops. But of course, that is actually very dangerous because when you lock the car tires, actually the car will still continue be moving on because of the inertia of the car. When the car when the car move forward, and when you lock the car tires, the car will want to continue move forward because of the inertia. Right or not? And this thing is called skidding. It's called drifting, basically. Skidding of the car. And it's very dangerous one because when the car skid, you cannot control the direction of the car. You cannot control where the car wants to go. So that's why it's very, very dangerous. So instead of that, right? So that's why engineer design, when you apply brake pedals, okay, on the car, now the tire will not be locked entirely. So instead of locking the tires to slow down the car and stop the car, the car tire will rotate and stop in a very high frequency. So it will be, the lock will be locking the car tires, but at the same time, like I said, locking and releasing. So all this, right, they are done automatically when you don't have to do it one. So the car will activate itself, the ABS, anti-lock braking system. So it will prevent the car tires from locking. But at the same time, like I said, locking, releasing at a very, very fast speed. So, and by doing so, right, it can make the car vehicle, it will make the car to stop even faster. All vehicles with tires. So same thing goes to this truck. So it will make this truck to stop even faster, more effectively. Using shorter distance, shorter time, it can slow down the truck and stop the truck. Okay, so the most important reason, like I said, we install this anti-lock braking system. It's all because we want to prevent, so this thing, just now we used the word skidding, right? To prevent the skidding of the truck, because like I said, when the truck skid, the truck driver cannot control the direction of the truck one. Okay, when it skid, so it will just all go according to the inertia of the car already. You cannot control the direction of the car. Okay, very dangerous. So that's why we need this ABS. Yeah. Then the third one. So next one, the third one, the question wants you to choose the gap between the truck and the fuel tank. So if you look at the diagram, can you see? in between the truck and also the oil tank, in between there's a gap one. So do you want this gap to be big or do you want this gap to be small? Closer gap or further gap? So this one, we will always choose the gap to be greater. Further gap. Increase the gap. Or you can also use the word increase lah. Increase the gap. Increase the gap between truck and the oil tank. Do they use the word oil tank? No, they use the word fuel tank. Just follow lah the question. Fuel tank. So increase the gap between truck and fuel tank. And why? Because the greater the distance, then harder for the fuel tank to collide with the truck. Like I said, when the truck move forward, the fuel tank and also the fuel inside the tank will also move together forward together, right? Move together forward. But when the truck stops, okay, when the truck brakes, the inertia of the fuel tank and also the fuel inside the tank will continue to move forward because of the inertia. So causing them to continue move forward. So and then when the fuel inside the tank hits the oil, hits the wall of the tank, it will create a force, and then this tank, right, will move forward a bit one. So it might hit the driver inside the truck here. So that's why to prevent that from happening, we want the gap to be greater lah. Okay, further gap, increase the gap. Yeah, so this one to prevent. It's because we want to prevent the collision between the fuel tank and also the truck, so that they too won't collide each other. Okay, then another tool, right? You have to think of your the extra features, the other features to make this truck to become more safe. Now, what else? Can you guys think? Because you guys can tell me some answer. You guys can suggest some answer to me, because so that I can tell you whether your answer is right or wrong. Yeah, you can try. So that's why I always encourage you all to try, because when you try, you are giving me your answer. It's okay, you are giving me wrong answer. At least you know that answer is wrong. Knowing your answer is wrong is also making progress. At least you know that one is the answer you shouldn't be writing in your exam. Okay, so for this one, let me give you one now. Okay, so meanwhile you can think of another one. Now, for mine answer, I give you a more uncommon answer. For this one, right? Have you guys noticed at the back of the oil tanker truck, sometimes, right, you will see, not sometimes, it's actually all the time. So it's just whether you notice it or not. So if you never notice, try later, starting from today onwards in the future, when you are on the road, if you see oil tanker truck, when your parents drive on the road and you see an oil tanker truck, right? At the back of the oil tanker truck, they will put a belt made of rubber. Sometimes they use metal chain connecting the tank to the surface of the road one. So that means the chain or the belt will be dragging on the road. It will be touching the road, and then it will be pulled all the way, dragging on the road one. So do you guys know why we put this? Why the truck driver and also the one who designed the truck, they put a metal chain and also the rubber belt and leaving it touching the ground? It's because, right, you know, when truck move forward, right? I mean, not just the truck lah. Every object, when they move forward, I mean, air resistance will also be produced at the same time, because when you're moving forward, the air will be blowing towards the object directions. If the object is moving forward, then the air resistance will be acting backward. So that means towards in the face of the truck lah, right? So and then remember, air particles, the frictions between air particles and the body of the truck will also cause electrostatic charge one. So have you guys tried, you know, getting shocked by your friends or your siblings, your parents, or with some other objects, electrostatic charge? Now, why do you get electrostatic charge? Why do you get electrostatic shock? It's because when one object has more positive charge and another object has more negative charge, when their charge is imbalanced, and just so happen, coincidentally, right, if one object has more negative charge, another one has more positive charge, the object that has more negative charge, right, those negative charge will jump towards the body of the positive charge. So the jump of the charge will cause a shock. And that is actually the spark. You will cause a spark. But spark is actually not a thing. But of course, spark in the oil tank is a thing. I mean, to us, it's not a thing because you just feel a bit pain. But if a spark happens in the oil tanker truck, you have to understand also, because if there is spark, this spark can cause fire. And all these thing, all the thing inside the tank is fuel. Fuel, they are all combustible one. Right now, they are what do you call it? Flammable. Yes, they're flammable. They can cause a fire easily. So if let's say if it's even serious, right, it can cause explosion. So that's why all the charge caused by the frictions between air resistance and the body of the truck has to be discharged. All this electrostatic charge need to be discharged. Discharge means release away from the truck. So to prevent explosion or the combustions of the fuel. Yeah, so that's why for a safety feature, because now it's not just related to like not related to inertia, you also have to answer things about safety features. So all your answers, right? See, just now we were all discussing all about inertia, right? The first three answers, they are all about inertia one. But so the question is asking you to give to design this petrol tanker to become more safe to transport the fuel safely. So that's why after this, okay, the other two doesn't really related to your inertia anymore. Okay, sometimes you need to think creatively, out of the box, other answers. Yeah, so this one usually they will use rubber belt or they will use metal chain. Just write whichever one now. Okay, don't need to write two one. Sometimes rubber belt, sometimes metal chain. Go and notice if you don't know. If you never noticed before, then starting from today, you go home and notice. Okay, so behind what? Behind the truck. Why? Like I said, it's because this thing is actually to discharge. The function is to discharge. Discharge what charge? Discharge the electrostatic charge. Electrostatic charge. So produced by what? Why does the truck have all this electrostatic charge? Produced by the frictions, because friction produce charge also at the same time, produce heat. So produced by the frictions between what? Between the air resistance and the body of the truck. So there will be a lot of electrostatic charge on the fuel tank one, on the oil tank. So, and it's very dangerous. So that's why need to be discharged. Clear? So last one. Any answers you want to suggest? Any answers you guys want to suggest? That can make this oil tanker truck to be more safe one. Now, there's another one. Let me tell you this one. Is by increasing the number of tires of the truck. Have you guys noticed? All this oil tanker truck, right? They have a lot of tires one. And in the diagram here, you can see there are 3 tires on each side. But actually, do you guys know that actually this one, usually they will put 2 tires at one side one. So it's like 2, 4, 6. They have 6 tires on one side. Then on the another side, they also put 6 tires. So in total, there are supposed to be 12 tires for the oil tanker truck. Do you know? Every tire, they actually install parallelly with another tire one. So one tire actually inside, there's still another tire one, together touching the road. Now why? So it's like if you see from the bottom, you see something like this. There one tire, then another tire. So got 2 tire one. Now why? It's because using more tire, it will increase the area of the tire in contact with the ground, because the truck is very heavy. So if the tire is too little, it will create a large pressure onto the ground and it will damage the ground. So that's why, and also it will damage, it might not be able to withstand the weight of the truck. So the weight of the truck has to be distributed throughout more tires. So then the truck won't be easily, the tire won't be punctured easily okay, because of the pressure. Because if you have so much of weight on the oil tanker truck, and then all stressing on little tires, right? Little amount of tires, right? Then the tires can puncture easily one also. Okay, so that's why we need more tires. So tires is also another safety feature in the vehicle, on the road vehicle. Yeah, so this one, what you can write here is increase the number of tires. So if you're able to choose when you're modifying, right, increase the number of tires of the truck. Why? Like I said, more tires, and then it will distribute the weight of the truck. And so the pressure of the truck acting on the ground will be lesser. And so also it will prevent the tires, right? It will prevent the tires from breaking easily, or from bursting easily. Okay, because you reduce the pressure of the truck acting on the road. Here, this one, you write to reduce. It's because you want to use more tires to reduce the pressure of the truck acting on the road. Clear? This one, not too hard. So you will see this kind of questions one in your exam. So that's why you have to practice a lot. Because when you practice a lot, you see this kind of question before, then in the exam, you won't be panicked. You don't need to waste time thinking for the answers anymore. So if you did this question before, so most likely you will know what to write in your exam if you see the same type of questions. For example, if we did this question before, I mean, we did this question together now, and then later on in the exam, right, if this question came out again, a similar type lah, maybe not the truck, okay, maybe some other things, but you will know lah, okay. But of course, for some other trucks, then they don't need the rubber belt and the metal chain lah. They need more number of tires also, right? They also need more number of tires if you are designing a big truck. Also need more numbers of tires. So, but at least if you did this question before, and then in the exam, if similar question comes out, then at least you know how to do. Okay, come, let us do another one more question. On page number 11, the next question, question number 4. So question number 4 here, it says, but of course, again, like I said, I want you to look at the diagram and then tell me lah. Okay, you try to think which subtopic does this question belongs to. Yeah, so this one question says, if you look at diagram 3, it shows an watermelon falling off from a 2.5 meter tall table. So you can highlight sometimes when you read the information, right? Watermelon falling off from 2.5 meter tall table, and then dropping onto the floor surface. And then the watermelon mass is 1.5 kg, experience the change of momentum of falling. So the question also tells you that when the watermelon drops onto the ground, the momentum change. So do you still remember this question? When momentum change, it creates this collision force. Do you still remember the name of the topic when we learned this thing? It's called impulsive force, right? If you remember, it's called impulsive force. That subtopic is impulsive force subtopic. Impulsive force. So it's a question related to this subtopic called impulsive force in chapter 2 that time. Yeah, never mind. Come, let us look at the question then. 4A, then question asks, what is meant by free fall? So what is the meaning of free fall? So if you remember, right, free fall is a falling motion. That time we discussed before also. All this question we did it before in normal class before one. So we are just revising only. Free fall is a falling motion. That means the movement of an object falling. But you have to be more specific. You have to say only under the effect of gravity. So when we use the word only, right, that means it has to be an object falling under the effect of gravity, only and only gravity. That means there must be no other factor affecting the falling motion. So let me show you, right? If let's say this bottle falling down, this one is not called free fall because this object falling down, it is not just affected by the gravity, but at the same time, when this object falls, there will be air resistance acting on it. So the air resistance will be another factor that is affecting the falling motion. So that's why, remember, free fall, right? It has to be carried out in vacuum condition. So that means must not have air resistance one. So when object falls under no resistance, only then we consider that falling motion as free fall. If not, it's not free fall. Okay, so this one actually in the diagram, when the watermelon falls onto the ground, right? This one also it's not supposed to be called free fall lah. Okay, but of course, when we do the calculations, we will consider the watermelon is falling under free fall. Why? Because when we do calculations, we don't consider in the air resistance. So that's why we will consider when we do calculations, okay, for this question, we will assume that there's no air resistance, and we will assume that the situation, The falling motion is a free fall motion. Okay. So for B1, then the question asks you to calculate the time taken for the watermelon to reach the floor. So how long will it take for the watermelon to reach the floor? Time taken. So the time taken for the watermelon to reach the floor can be calculated using this method. Do you remember the linear motion equation? Linear motion equation method, SUVAT, the SUVAT questions at that time we learned. I think we discussed like at least 3 weeks that time during February. SUVAT questions. So SUVAT, there's no such thing as SUVAT one. So SUVAT, I call it SUVAT because it's actually the short form for 5 quantity. The short form are the symbol for 5 quantity. So each of them, SUVAT, they are a quantity. Okay, they are a quantity. So like S is the displacement, if you remember. U is the initial velocity. V is the final velocity. While A, acceleration, lastly time. T is the time lah. Okay, just fill in the list with all of the information given in the question. Like for example, now when the watermelon fall to the ground, the distance for the watermelon to reach the ground will be 2.5 meters, right? So that's why the displacement will be 2.5. So just put in values into the SUVAT list. And if you remember that time we discussed, right? If the question tells you that the object is falling means the object at first, before the object falls, the initial velocity of the object should be 0. Okay, so you need to remember the keyword. If you see the word falls, if you see the word drop, as long as you see the object is not being thrown, because if the object is being thrown, right, there will be initial velocity of the object one. But if the object is being dropped, that means the initial velocity of the object is 0. Okay, and then final velocity is not given by the question because the question did not tell you what is the final velocity of the watermelon before reaching the ground. So every time remember the V, right, the final velocity is supposed to be the velocity of the object before hitting the ground. So imagine like this is the ground and the object, when the object falls, the one moment before the object touches the ground, that speed is called the final velocity. So we do not have that, right? The question did not tell you what is the speed of the watermelon just before hitting the ground. And also, if you look at question number B2, right? Question part B2, actually that is what the question wants you to calculate later. Question wants you to calculate the velocity of the watermelon just before hitting the ground. So that means later on you need to calculate the V in the next part. But of course, this one, going back to the question, your acceleration is 9.81, while your time is not given. So this one, we put a question mark that time we learned before. We discussed before. Remember, I told you, you are allowed to put one cross. You're allowed to put one cross and also one question mark. Question mark for the quantity that you're looking for, and then cross for the information that is not given in the question. Okay, now this one, so because the question did not give you the final velocity, so use the formula that don't have final velocity. So do you still remember what is the formula? There are 4 linear motion equation. So you must remember them because I said in SPM, most likely they will be giving you, but in your first term exam, your Form 4 first term exam, most likely your teacher will not be giving you because in first term exam, right, there's nothing much your teacher can ask you. So that's why to increase the difficulty of the questions, right, your school teacher would not give you the formula one. So you have to remember, you have to memorize for this term exam, the 4 formulas for linear motion equations. So for the 4 linear motion equation, out of the 4, the formula that don't have V, right, is S equals to UT plus half AT square. Okay, you have to apply the right formula. Okay, S equals to UT plus 1 over 2 AT square. That is the formula you should apply for the question that you don't give you V. Because in the question, we don't have the V. And you are looking for T, right? So just put in values into the formula accordingly. So like for example, the S is the displacement of the watermelon falling to the ground. So displacement will be 2.5. And then the initial velocity of the watermelon is 0 plus 1 over 2 times acceleration times t squared. So 1 over 2 is just a factor number. So just multiply the 1 over 2. It's just the formula number. So just follow only. So 1 over 2 multiplied by the acceleration, which is 9.81. Hold on. Why like that one? 2, yeah, this one. Then acceleration will be 9.81. 9.81. And then multiply by t squared, because t is your unknown. So just leave t as t lah. So whatever that you're looking for, just leave the unknown as the unknown. So just don't change it, because that's how you know that's your unknown that you're looking for. Clear? So it will be what? It will be 2.5 plus equals to 1 over 2 times 9.81 t squared. Okay, let me crack my back. Okay, quite pain. Now this one, okay, so 0, then you don't have to write anything now, okay? Then this one, 0, then you don't have to write anything. So just write that this one, 1 over 2 times 9.81 times t squared. So just calculate the value of 9.81 divide by 2. Because 1 over 2 means divide by 2 lah. So then it will be 4.905. It will be 2.5 equals to 4.905 t squared. So to find t squared, you have to do a bit of algebra expression. So t squared then will be 2.5 divided by 4.905 t squared. So this one, it will be 2.5 divided by 4.905 equals to t squared. But of course, you can just straight away and go and calculate how much is 2.5 divided by 4.905. So 2.5 divided by 4.905, it will be 0.509. This value will be 0.50968. Now, the more decimal points you use, right, the more accurate your answer will be. 68, then 3. Of course, you can use the actual value, but of course, when you also, if you want to show your teacher the working, you can write maybe like 3 decimal points, but when you calculate, use the actual value to calculate. Because when you use the actual value to calculate, you will get the most accurate answer. If you use the round up answer to calculate your answer, you use a round up value to calculate your answer, then your answer will be slightly deviate from the actual answer one. So to get the t, now this is not the answer for t yet, because you are finding, I mean the answer 0.5091, that one is equals to t squared. See the square? And the question is asking you to find the time, not the square of the time. So you have to square root both sides right now. Square root. So square root of t squared will be t. Square root of 0.509, then will be 0.719. Sorry, 0.714 seconds. But of course, you can just write 0.471. If you want to write 3 decimal points, also can. You're welcome. Then remember the unit, seconds. Okay. Now, next one. So again, like I said, the next part is actually the same type of question. It's just the question asks you to calculate the final velocity. So instead of saying that you don't have the v, now the question is asking you to find the v. So you put the question mark to the v, but now assume that you don't have the time. Even though you already know that the time taken is just not the one we calculate, 0.714 seconds. But we will assume, so many of the times we'll assume, try to assume that you don't have, because there is a possibility you calculate this answer wrongly. And if you're going to use this answer for the next part, right, if you calculate wrongly, I'm saying if you calculate this answer wrongly, then if you put it here, then later when you do these calculations, right, even if you do it correctly, but the value you use is wrong, then your answer will be wrong also. So it will be very kasian, right? Because you should be getting the right way. I mean, you should be getting the right answer because you're using the right way. Just that because you're using the wrong value, so that's why you got the wrong answer. So very kasian, right? So that's why I said, try not to use the value you calculate yourself. But of course, sometimes, right, you cannot avoid one. Sometimes is inevitable one. You have to use the value you calculate. But in the case that where you don't need to use the value you calculate yourself, then it will be better. Use the value given by the questions. Don't use the value you calculate yourself if you get to choose. Okay, so without t, right? Without t, then you have to apply this formula. So the formula that without t, right, is v squared equals to u squared plus 2as. Okay, v squared equals to u squared plus 2 times a times s, 2as. All right. So just sub in the values accordingly, then you will be able to find the value of B. So U is 0. So 0 no need to write lah, because 0 square will be 0 also. So whatever multiplied by 0 becomes nothing. So nothing means you don't have to write now. Yeah, so 2 times acceleration and times the distance, the displacement. So the A is 9.81. 9. Don't know why like that. My pen ink always merge. So 9.81. And then multiply by the distance of the watermelon falling down. It will be 2.5. Right now, 2.5 meter from the table. So then after multiplying, you should be getting your V square. The value of the V square should be equal to 49.05 meter. Sorry, not meter. So just the value lah. So what's the unit of this value? Don't know, because this is not your final answer yet. Because this answer for 49.05, this answer is equal to V square, not equals to V. So V will be the square root of V squared, right? So it's also going to be the square root of 49.05. So you got to press your calculator, put in your value, 49.05, square root, then your answer will be 7.0035 meter per second. But of course, because you will be getting a value of 7.00 already. So that's why you can just leave your answer in 7. Okay, just without decimal point also can. So 407 meter per second. Okay. Now then the next one, number 3, the third one. So the question asks, the watermelon hits the floor surface and breaks upon landing. So question wants you to calculate what is the change in momentum of the watermelon when it hits the floor. So when it hits the floor, right, the change in momentum will be very simple actually. To calculate change in momentum, remember just now, momentum. How do you calculate momentum? For a very simple method, if you want to calculate momentum, use mass multiply by velocity. But now the question is asking you to find the change in momentum. So to find change in momentum, you use the final momentum minus the initial momentum. But because remember just now we discussed at the starting of the question says the watermelon is being dropped downwards one. So drop, just now I said, what does drop means? Drop means at first, the initial velocity of the watermelon is 0. There are no speed for the watermelon. Okay, so the mass is 1.5 kg. Okay, 1.5 kg. So that means your answer will be just mass times final velocity. No need the initial velocity one, because no need the initial momentum one. And let me show you why because your initial velocity of the watermelon is 0 ma. Right? And then just now, from the previous question, we already found out that the final velocity before the watermelon hits the floor will be 7 meters per second. Then minus what? Minus the mass of the watermelon, which is 1.5, then multiply by 0. So that means that's why I say your momentum, your initial momentum will be 0, because the initial velocity is 0. So there will be no momentum initially. Yeah. So then your answer will be just 7 multiplied by 1.5. So 7 multiplied by 1.5 will be 10.5. Then don't forget the unit of momentum. Just now we discussed. It'd be kg meter per second. Kilogram meter per second. All right. Yeah. So that's your answer with the correct unit. Now then the next one. Question C then asks, take the correct statement about the impact time between the watermelon and also the floor surface. So you have to understand if the question shows you that the watermelon breaks, means the impulsive force is quite big. So that's why the watermelon breaks, right? So but why it breaks? It's because the wall, the floor is hard. And remember that time we discussed before, when the object is hard, when object collide with a hard surface, the time of impact will be shorter one. Imagine you hitting the wall. Your fist will be stopping immediately after hitting the wall. So the time of impact is very short, causing the impulsive force to be greater. But when you hit something that is soft, right? For example, if you put a cushion between the wall and also your fist, when you hit the wall with a cushion, the cushion will compress. So and when the cushion is compressed, right, it will be taking a longer time for your fist to stop. The collision time becomes longer, then the impulsive force will become lesser. Okay, so remember, impact time is also a factor affects the impulsive force. Clear? So remember, hitting hard surfaces, impulsive time, the impact time is shorter, causing the impulsive force to be greater. Yeah. So moving on to the next question. So we still got another 2 more questions before we end. Question D, last one. Second last one. So the second last one question asks, why does the watermelon break when the watermelon hits the floor surface? Why? Now this one just now we discussed right? For a most obvious answer, right, is because the watermelon cannot withstand the force. So that's why it breaks. Right not? But why it cannot withstand? Because the force is too big. Right not? So what you need to write here is very simple. Just write when the watermelon hits the floor, what happens? At the time of impact, remember just now we discussed? The time of impact between the watermelon and the floor surface. Okay? The time of impact between the watermelon and the floor surface is short. Very short. Okay, so for a very short moment, the watermelon stops immediately. So then the impulsive force, it will be greater, right? Now, the impulsive force between the watermelon and also the floor will be large. Or you can also write it's large lah. It will be large because the time taken is short. So then, due to the reason that the impulsive force is so big and the watermelon cannot withstand the large force, right? Watermelon cannot withstand the large impulsive force. Okay, so that's why it breaks. So between the floor and also the watermelon, so that's why it breaks. Clear? So that's the explanation. Now, then the last one. Now, last one, it's also another essay question. So this essay question, right, is the hardest kind. Why? Because remember that time I told you before, essay questions, there are 3 types. Number 1 is the choosing type, where you just have to choose based on the characteristic given in the table. So second type is the suggestion type, and not the suggestion type, sorry, modification type, the one we did just now. So they will give you expect for you to modify. They will tell you, oh, you have to modify the compartments of the truck. Remember just now? So the last one, the most hard one, the hardest one is this one. It's called suggestion type, where you have to give suggestions based on nothing. You have to think yourself lah. Okay, whatever thing that can make this car become more safe, you have to write. Now, so this one, very simple one. You read the question. Question says you are required to give some suggestions on how to design a car so that it can save life of the driver and the passenger during a car crash. So that means you have to make this car to become more safe. Safety level has to increase so that this car can save the life of the driver and the passenger. So using the knowledge of the force, they tell you use force, use motion, use properties of the material, and then explain the safety feature that should be included in the car. And also at the same time explain your characteristic choose, your choice of characteristic. Yeah, so this one, let me discuss together with y'all. Okay, so this one is actually inside the table, just not at page number 3. Answers are all there. But of course, I want you to think of yourself and then we discuss. So that's why we take this opportunity to discuss together. Okay, so for top right corner, you write reasons. So top left corner, you write reasons and characteristics. Top right, you write reasons. Now this one, so for the characteristic, right? Do you still remember for a car, right? How do we design a car to make this car to become more safe? Now, for the front part of the car, this part, remember this part? What do you call this part? This part, right? We call it the soft crumple zone. Now, this crumple zone has to be soft. Remember or not? I said this part of the car, they will make this part of the car purposely to make this part of the car, right, to become more soft one. So it's called crumple zone. So you can write soft crumple zone at the front and at the back of the car. Actually, at the back of the car also, they will purposely make that material to become softer one, because they want that part of the car to crumple during a car crash. And because crumple will increase the time of collision. Yes, I understand when it crumples, right, it will reach let's say another car crashing to another car. So if the crumple zone is soft, the car from another car, right, another car will hit another car and it will be faster reaching the driver inside. But By increasing the time of collision, right, the force that transfer into the driver and the passenger will be reduced greatly if the crumple zone is safe, if the crumple zone is soft. So that's why remember, even though soft is easy to break, but at the same time, like I said, soft means you're increasing the time of impact. So increasing the time of impact also can save lives. Okay, it will be more important to save life by increasing the time of impact, reducing the impulsive force. So remember, soft crumple zone at the front and at the back of the car. Okay, so the car front and the car back has this part called soft crumple zone extra soft. Again, because you want to increase the time of collision. That means when two cars collide, we increase the time of collision, and by increasing the time of collision, you are decreasing the impulsive force. So that's why you need this soft crumple zone. Okay. Now then the second one, for the second one, remember, it's also about impulsive force one. So in a car, we want the car to have this thing called automatic airbags. Have you guys heard of this thing? Or you can also write automatic safety airbag. It will inflate automatically to act as a cushion during large impulsive force. I mean, large accident. Okay, in a very serious accident, when the car crash, the car will detect a very large force, and then that's the moment, right? The automatic airbags will inflate automatically in a very short time. That means very fast, it inflates and then act as a cushion. It's actually inside the dashboard of the driver and also the co-driver seat. Okay, so to act as a cushion, okay, and absorb impact, okay, during an accident, during a collision or during an accident, okay, so it will absorb impact. Clear? So then the third one, then for a car, right, a car will have, inside the door of the car, side doors, right, they have this thing called side impact bars, side impact bars. So side impact bars, the reason there, I mean, this is a very strong material, or you can also write strong steel side impact bar. So the side impact bar should be made of strong steel. So strong steel, because steel is an alloy, they are stronger than usual metal, the pure metal, so, and they can protect the driver and the passenger from side-on collision. To protect the driver and the passenger from a side-on collision. That means when a collision happens from the side, the side impact bar can protect the driver and the passenger. Clear? Now, then the next one, what else? What else do you guys suggest for a car to have? What features do you guys think that the car should have to make this car to become more safe? Now, yes, okay, I think safety seatbelt is also another good option. You can write safety seatbelt. Now, you guys can suggest, because if you don't suggest, I don't know whether your answer is right or wrong. Then later on, you try this answer in the exam, then it's wrong. So at least you try now. Then at least I know whether your answer is right or wrong. And again, you don't have to copy the answer one. You guys can just listen, and then later on, you guys can get a screenshot for the answer from me, right? And so that you don't have to, you can pay more attention in the class, I think. Okay, but it's all up to you, okay? Now, but again, why do you want a safety seatbelt? It's because, right, you want to prevent the driver and the passenger, okay, from being thrown out of the car due to inertia. Remember, not inertia? When the car is moving, the driver and the passenger will be moving forward also. But during an accident, the car will stop immediately. So, but even though the car stopped, the driver and the passenger will want to continue move forward. So when the driver and the passenger continue to move forward, they will be thrown out of the car. So being thrown out of the car due to the effect of inertia, or you can just write due to inertia. It's also the same reason. Okay. So remember that. And then the last one, just now we said the driver and the passenger, they might be thrown out of the car, right? Now, they might be thrown out of the car. So how do you prevent them from being thrown out of the car? Because when they are being thrown out of the car, they have to go through the windscreen, right? So the windscreen must be a shatterproof windscreen so that they won't be thrown out of the car. But of course, shatterproof windscreen is not because they don't want the driver and the passenger being thrown out of the car. It's actually to have shatterproof windscreen. It's because sometimes in the accident, right? Like last time, there was one case in an accident. The driver didn't die from the accident, didn't die from the collision, but the driver died because during that accident, when the car crashed, right, the windscreen shattered into pieces, and then the pieces cut the driver, and then causes the driver to lose a lot of blood, and then in the end die. So that's why from that incident, we learned that from that incident, the windscreen cannot shatter. They cannot break into pieces and then cutting the driver or the passenger. So that's why the windscreen has to be shatterproof one. So how do they make it to become shatterproof? They make windscreen become shatterproof, right, by sticking two layers of windscreen together. Two layers stick together. And so when one layer shattered, right, they will stick onto another layer. So it's actually a technology. Okay, we call it tempered glass. It's actually the same meaning as the tempered glass you use for your phone protector. Okay, phone screen protector. It's actually the same concept one. So that's why your phone screen protector, right? They don't break one. They don't break into pieces. When they break, they will stick onto another layer of the glue one. So it's actually two layer. Okay, so it's called tempered glass. Just to let you all know lah. Okay, so remember this one. It's because you don't want to prevent what? To prevent the cutting injuries to who? To the driver and the passenger from the shattered pieces of the windscreen. Because like I said, if the windscreen breaks into pieces, it will cut the driver and the passenger. And then it might cause cutting injuries, losing too much of blood. If it's serious, then the driver and the passenger might die from it. Might die from, losing too much of blood. Yeah. So, and yeah, that's it for today. And there are many, many more other questions at the back. So I want you to go home and try all that questions. Anything you don't understand, right? Just come and ask me. I'm always here. But remember to ask me early, because if not, I take some time to reply you all one also. Okay? So go home and do all the questions. If you don't know how to do, right, can look at the answer and do. And then don't just copy answers lah. Try to understand why the answer for that question is like that. Why do they ask you that questions? Okay, so and also try to understand the answer, why the answer is like that. So understand the reason behind the answers. Okay, so answers are all, like I said, on our official website. Just type in the Google TTC Education, find the PDF soft copy answer and notes. There you can find. It's actually a link to a Google Drive. So just find the respective subject you want to. Okay, every subject, all the notes and also all the answers are posted there already. Okay, like I said, in the Google Drive there. Okay, at the link on our official website. Yeah, so that's all for today. The rest of the questions, please remember and go home and do. Now, trust me, there will be definitely at least more than half of the question that will come up in your exam. I guarantee you, at least half. I said the type of questions cannot be exactly the same, but the type of questions will be at least half same questions as your exam. So whether you believe me or not, you can try. You can try doing first, then later on you will thank me one. And then also later on, right? Trust me, you go and compare lah. You go and compare your school exam paper and the exercise questions that we give you. If you don't do, you will regret one. Trust me, every year also the same. I've been saying this all the time, but depends on student whether you want to listen or not. Okay, so I'm sure you guys can do it. Okay, remember, victories come always after hard work. Yeah, so that's it for today. I will see you guys next week in the normal class. Thank you everyone for joining. I will see you again when I see you. Bye bye. Okay, bye.